All right, hi guys. We are going to continue on. This is still Module 4, Investigation 8, same one we were working on yesterday. We are going to keep working with our logarithms. Okay, so, whoa, hitting buttons here. Suppose well, let's start with this. We know that 10,000 is equal to 10 squared times 10 to the third. Think about that for a second, and do you agree with that statement? 10 squared is 100. 10 cubed is 1,000. Oh, wait, I need 100,000 there. 100,000. Because 100 times 1,000 would be 100,000. Okay, so hopefully we're agreeing that is correct now that I actually have 100,000 there, not 10,000. Okay, and we know that, of course, would be the same as 10 to the fifth power, because when you are multiplying the same bases, you add the exponents. Okay? All right, now suppose we want to find log of 100,000. Well, this is a common log, right? Which means it's base 10. Okay, couldn't I rewrite this as log of 100 times 1,000? Right, so I can replace the 100,000 with 100 times 1,000. So, of course, I could rewrite this as log of 10 squared times 10 cubed. Nothing wrong with that, right? That's all equivalent. So I think then I could also rewrite this as log of 10 to the fifth power, because when I'm multiplying bases, I add the exponents. So hopefully you are agreeing that this is all valid and this is all okay, and we can do all of this. Well, what would log, we know it's common log, so base 10 of 10 to the fifth be? So again, remember this is really a base 10. I'm asking you to solve for what this might be. So if you could think about changing forms, 10 to the x equals 10 to the fifth. So I hope you would agree that this is equal to 5. And isn't 5 equal to 2 plus 3? Right? You with me on all this? So I think I could also make this log base 10 of 10 squared. There's my 2. And I know this is base 10, and hopefully you're seeing that anytime you have log base b of b, it's always going to equal whatever that x is. We talked about this a little bit at the end of class yesterday with the natural logs and the e's, those always canceling, and it happens anytime your base of your log is the same as what you're taking the log of. So then I think I could also make that, so this part would give me 2, and I could make this log base 10 of 10 cubed, and that would really just be a 3. So you're probably sitting there like, why the heck did you do all of this? Because from the very beginning, we could have just figured this out and it wouldn't have been a big deal. It was just 5. Why did we do all this? Well, the point of doing this is because we are going to have 3 big properties that we learned today, and this is the first one. The first of the 3 properties says if you have log base b of m times n, you can rewrite it as log base b of m plus log base b of n. Why? Why is that true? Well, go back through here. Right here, we have log of a product, and we rewrote it as 2 separate logs that are being added. You can use similar arguments for the other 2 properties. I'm not going to go through them, but it would be very similar to what we did up here. So the next big property, log base b of m divided by n, Now think about this. If multiplication, log of a product, becomes addition of two logs, log of a quotient, what do you think it's going to become? It's going to become the difference of two logs, which should make sense because we know when we're multiplying bases, we actually end up adding the exponents. And when we are dividing the same bases, we subtract the exponents. So hopefully you're seeing how those are related. If you're super curious, when I get back, I'll go through a problem and show you, but I don't want to spend too much time on the video doing that. Third property, log base b of m to the c power can be rewritten as c times log base b of m. All right, so we're going to do a few examples here. Number 1, express as a sum of logarithms. So they're even telling you exactly what it's going to become. In other words, this is also known as expanding. Okay, so you're taking a single logarithm and expanding it into two separate ones. So what would this be? Log base 3, base stays the same, of 81 plus log base 3 of 27. These properties also hold for natural log because, of course, that's just a log with a base e. So this one would be natural log of x plus natural log of y. Okay, let's look at number 9. I have an exponent. An exponent comes to the front, log base b of t. There's still only a single log. You just need to remember that that exponent can come to the front and get multiplied there. That was the third property we learned. Moving on down, if we were to look at, let's do 18. Okay, that's going to be log base a of 76, and then what operation do we need? It's division of a single, or it's log of a quotient, so now it becomes two logs that are being subtracted. And there you go. Okay, so those are the basics. Now let's get harder. All right, I'm going to do 23. I've got a bunch of multiplication. Every single place you can split it up, you have to turn that into another log that's being added. What most students will do is they'll remember to do it between here, and they'll forget to do it between the 6 and the x. So don't forget you've got to split off that coefficient. This becomes log base a of 6 plus log base a of x plus, watch this one, that 5's on the y, exponents come out front of the log. 5 log base a of y plus, again, 4 comes out, 4 log base a of z. Okay, that was 23. Okay, I'm going to do 25. So I see multiplication, I see exponents, and I see division. So there's a lot happening here. I need to take the products and make them separate logs with addition between them. And I need to take the quotient and use subtraction, and all of my exponents are going to have to come out front. So I'm starting 2 log base b of p. Okay, that took care of all that. Plus, because I had times, 5 comes out front, log base b of q. Now I've got a quotient, so I have to do minus. Be very careful here. You're dividing then everything that comes after it, so you need parentheses. 4 log base b of m, and then between the m and the b there's multiplication, so that's a plus, and we're good because we are putting parentheses around this so we know all of that is coming from the denominator. So that would be 9 log base b of b. Okay, hopefully you followed along with that one. Now let's do one of these radical ones. Let's do 32. So the first thing I would recognize is that I could rewrite this as the radical being an exponent. So this would all be to the 1/3 power. So then what I would do is I would actually put that 1/3 power on everything. So I would have y to the first power, z to the 2/3 power, and x to the 4/3 power. Now it makes it easy for me to expand. So I've got log base c of y plus 2/3 log base c of z. And then now I've got division, so that becomes subtraction when I split it into two logs. Oops, and I forgot I got to put my 4/3 out front. 4/3 log base c of x. Okay, hopefully you guys are following along with this pretty okay. I'm sure Mr. G back there would jump in and help you with this if you guys are needing it. So please ask if you do. Okay, so this should now feel very familiar to that very last problem on your homework that some of you asked me about, and I told you I wasn't going to help you because it was in the pre-class. All these three properties were in your pre-class. So hopefully you figured that out for that last half a point on your homework from yesterday. If not, now you know how to do it, and your next homework assignment has tons of these to practice. I know that's your favorite, lots of homework practice. So tonight, let me get to a new screen here. Tonight you have homework 24, and that is from Module 4 Investigation 8. It's all about the properties of logarithms. And then you have all the pre-class stuff for Module 4 Investigation 9. Okay, so two things tonight. These are due tomorrow. Please work with each other. Ask Mr. G if you need assistance. Utilize the forum as you're doing your homework. And please feel free to email me. I will have my phone on me while I'm at my math conference. So anything you guys want to ask over email, you are welcome to. If you need a little guidance or anything, please let me know. Okay, there you go.